Hello and welcome to Advancement in Clinical Trials. I'm your host, Rittika Dutta. Today we are diving into a frontier that's challenging the very DNA of clinical trial design, synthetic control arms. Our guest is Sumanth Mayur, who completed his master's in pharmacology from lovely Professional University and has been following the integration of real-world evidence and AI in trial design closely. Sumanth, welcome to the show.
Thanks, Rittika. Super delighted to be here. It's a fascinating and fast moving space.
It is really. Let's start by zooming out a bit. Epistemologically speaking, how do we assess the reliability of AI-generated synthetic control arms, especially when the underlying data is observational in nature and lacks the randomization that has historically guarded us from confounding?
That's a central concern. We are replacing the gold standard of randomization with AI driven emulation. So we need to ask not only whether the model is statistically accurate, but whether it is epistemically defensible. That means interrogating assumptions, whatever we have, causal validity, and model transparency.
Right. And that brings me to the next layer. When we say that these synthetic arms are comparable to the control groups, what exactly do we mean? Is statistical similarity enough, or do we need to fundamentally rethink what comparability means in a world where we simulate the counterfactual?
Exactly. What I would like to say is it's not just about replicating demographics or baseline characteristics. The real challenge is mimicking clinical trajectory, and AI models can sometimes overfit to the past rather than model a plausible present future scenario.
Speaking of overfitting, let's talk about biases. Real world data is full of systemic noise, racial disparities, fragmented care, treatment access issues. Is there a risk that AI just amplifies those biases and creating synthetic cohorts?
Well, Ritika, definitely. Bias propagation is real, and worse, it can become invisible once it's enforced into the model. And we need bias detection pipelines, fairness metrics, and possibly even adversarial training methods to actively mitigate this issue.
Let's shift slightly to the causal side. Current frameworks like G computation and structural causal models try to simulate counterfactuals. But do they offer the same causal guarantees that randomization does?
Mm, Short answer not yet. These methods have elegance in theory, but they require assumptions that are often unverifiable. In many cases, the faith we place in them is more mathematical optimism than empirical certainty.
Which leads us into regulation. What validation metrics or interpretability standards do regulators currently expect for synthetic control arms, especially when they could influence high stake decisions like drug approval or we'll have to cut this part off. I'll just say it
Okay.
again, which leads us to regulation. What validation metrics or interpretability standards do regulators currently expect for synthetic control arms, especially when they could influence high stake decisions like drug approval or indication expansion?
Well, regulators like the FDA and EMA are open, but they are cautious. They're asking for transparency, traceability, and increasingly explainability. We are likely moving forward. Hybrid no, my bad, toward hybrid models. Synthetic arms used in conjunction with smaller randomized comparators for validation.
Interesting. Now let's approach this from an ethical angle. If synthetic control arms become robust enough, is it still ethically justifiable to expose real patients to placebo or inferior comparators?
Well, that's a provocative time, but timely question, I would say. We might reach a point where running a traditional placebo controlled trial becomes ethically regressive, especially in oncology or rare diseases. Ethics will start demanding non inferiority plus transparency over outdated dogma.
That said, real world data tends to lag behind the present. So, how do we tackle temporal drift when the standard of care changes? Diagnostic tools evolve, but the data lags by a few years.
That's one of the thorniest issues. We need mechanisms to reweight, recalibrate, or even retire old data. Time aware models and continual learning pipelines might help, but they add complexity that regulators are still digesting.
Let's make it even more complex, let's say. But what about multimodal data? Can AI models robustly integrate genomics, imaging, sensor data into these synthetic control arms without overfitting or creating spurious correlations?
Multimodal integration is like the holy grail, but we are still struggling with dimensionality, missingness, and modality alignment. It's technically feasible, but statistically fragile. A few groups are making progress using foundation models and self supervised learning.
That makes me wonder, can these synthetic arms be transferred across similar trials? Say, using a synthetic control arm trained on one lung cancer trial and for another in the same therapeutic class?
I would say it's really tempting but risky. Contextual validity matters. Unless the inclusion criteria, endpoints, and clinical setting are near identical, you risk misrepresenting the disease context. We need robust transportability frameworks to access cross trial validity.
And finally, beyond all of this, are we looking at a deeper architectural shift in clinical trials? Are synthetic arms just the beginning of a move toward adaptive, continuously learning trial ecosystems?
Absolutely, I would say. The next 10 years could see trials evolve into AI driven, real time adaptive systems where synthetic controls, Bayesian updating, and decentralized data streams replace static designs. But this will require infrastructure, culture change, and epistemological humility.
That's a powerful note to end on. Thank you so much, Sumanth. This was both intellectually intense and deeply clarifying.
Thank you, Ritika. Love the questions and the depth of this conversation.
And to our listeners, if this conversation sparked ideas or questions, be sure to subscribe and share. Until next time, stay curious, stay critical.